Welcome to this special conversation on space safety and debris tracking. Today, we have the pleasure of speaking with Rosario Nasca, former head of space safety and at the European Space Agency and a leading expert in space situational awareness. Thank you for joining us today, Rosario.
Good morning.
So before we dive into technicalities, I would like to hear about a bit your personal journey. So you've had an extensive career and contributed significantly to the world of space safety. But how did this passion start? Was it always your dream, or did life guide you there unexpectedly?
Well, it was just a combination of opportunities and dreams. My dream was to fly. I was always interested in objects that fly, and was always trying to do experimentation and testing. And also, I'm of the generation of the ones that were kids when man landed on the moon. And this was very inspiring event. I still remember now having watched the landing on the moon in black and white on a very big CRT screen. Then after my studies, I joined the European Space Agencies after having worked in several industrial concerns in 1986. And I've been with the agency for 36 years. As my dream was flying and human space flight, I joined the Space Agency for the Columbus program, so for the development of the European module for the space station. This was in '86. I joined the program, and the flight of Columbus was supposed to be in 1992. It turned out eventually that Columbus flew in 2008. And development took much longer than expected because of various reasons, including Challenger disasters. So I worked on the avionics of Columbus. Then the agency is quite a large, European Space Agency is quite a large concern, so there are a lot of opportunities in the agency, a lot of projects in a lot of different disciplines and areas. Then I joined the Polar Platform ENVISAT program. So I was responsible for the procurement of service module of the ENVISAT platform, which is an 8 tons platform, which was launched in, I think, 2002, I think. Yes, 2002. And which has now still today a big contribution to space debris concern, because unfortunately at the time when we developed the Polar Platform ENVISAT, there was no many concerns about space debris. The issue of space debris was not even sort of existing, and nobody was worrying about making control re-entries of these spacecraft. So the spacecraft eventually was used until it died, and it is still there, and it's a danger for the environment, with an expected re-entry time in a couple of 100 years or even more, unless it explodes before. After the Polar Platform, I went again to human space flight, and I was responsible for the development of the laboratories that are inside the Columbus module. So Fluid Science Lab, Biolab, European Physiology modules. These are rack size payloads which are still operational on the space station. I was also responsible, for example, I was project manager of a number of external payloads of the space station. And the last payload that I left because I changed job, I left in 2012, I think. No, later, yeah. It is ACES, which is an atomic clock, which is going to be launched 25th of April. So it has been quite a long time in development. and it's going to be launched the 25th of April with the SpaceX launcher. In 2012, eventually, I joined and I became responsible for the independent safety office in the European Space Agency. This is an office which covers several disciplines. It covers human spaceflight certification, the safety of human spaceflight certification. Therefore, anything which flies to the space station has to go through a certification process. This office is also responsible for the planetary protection, which is another discipline concerned about exploration of planets and avoiding contamination of these planets to preserve science, as well as preserving the Earth environment from risks related to bringing samples from other planets. Nuclear safety for what concerns the risks related to the ESA activities with the nuclear power sources on spacecraft. And then last but not least, I was responsible for the space debris mitigation, regulatory requirement aspects, and re-entry safety. Therefore, in the period I was in charge of this office, we worked to the development of the ESA policy for space debris mitigation, including adoption of international standards, ISO standard at that time, development of the manual that to be given to the developer, and also reviewing all ESA spacecrafts for what concern the re-entry risk. Spacecraft that re-enter controlled or uncontrolled depending on the mass, and have to be the risk has to be within a certain threshold to be acceptable to the agency. So this is in a nutshell what I have been doing, and I've been sort of lucky of following the development of the area related to space debris mitigation and space situational awareness. Because in 2012, when I started, even asking a project manager to put enough propellant on the spacecraft to make control re-entry was asking too much, because of course it's penalizing the mass, because there was no need felt that you had to remove quickly the spacecraft, and then it had to be in the spacecraft in the ocean, in an area where there would not be risk to people. The situation have evolved very much because of launching becoming cheap. And then many more entities became interested in using of space. And therefore, number of spacecraft, number of launches have been going up and up and up and up. But I must say also the social responsibility is now felt more. Therefore, developers and operators were more keen in adopting measures for limiting debris in orbit, being able to maneuver in orbit, and so on. And this leads to the situation we have today, which is space quite crowded, with a lot of spacecraft, and the need to do something to manage it, because we have to live with what we have been doing in space since 1957. And we have also to make sure that we can keep doing business and can benefit from space around us.
That's very fascinating. Also because throughout your career, you basically brought us from the moment where the space sector started, and debris were not an issue, because of course there were not a lot of satellites until when it actually became a problem. So you basically, throughout your career, you lived through all these different stages. So also the concern about the space debris grew together with the
Yes.
evolution of your career. So that's very fascinating. And speaking of evolution, I saw that in a TEDx talk in 2019, you were speaking about some already impressive numbers about space debris. For example, I'm reading some notes. We are talking about 34,000 objects larger than 10 centimeter and millions more smaller than 1 centimeter. So how these numbers have evolved today? And looking ahead, what trends do you foresee in terms of debris proliferation?
Well, yes, I mean the numbers, what we is circulating, flying around us is being increasing dramatically, and it will be increasing. If you think that in 2010, I think there were about 1,000 operational spacecraft. Now we are at the range of 9,500, 10,000, depends on the way you count. It depends on who counts them. And this will be keep growing. 2030, it's expected to be close to 30,000, 28,000, 30,000, and then go to 2050, which the projection is for 100,000 spacecraft in orbit. Now, of course, with these spacecraft, operational spacecraft and so on, you have also all the other spacecraft which are left behind, and spacecraft that eventually have sort of catastrophic failures and therefore generating debris of smaller size. So according to the latest information in the European Space Agency report on space debris, now we have around 25,000, 30,000 objects larger than 10 centimeters, which are not operational. And for stuff which is larger than 1 centimeters, we are well above 1 million. So, and then if we go to objects below 1 centimeter, we have 100 millions or more on the thing. This is just to give the idea of how population is space. We have also to say the space is large. That's why we do not see too many accidents up to now, because there is plenty of space in space. Nevertheless, we have to take into account that even objects of 1 centimeter size can make substantial damage. In fact, a spacecraft hit by a 1 centimeter object with an enormous kinetic energy to the speed of the debris and the spacecraft can be disabled, and if we are not lucky, it can explode because the energy stored in the spacecraft in terms of propellant or in terms of electrical energy in the battery, the actual chemical energy of the battery can generate so much, release so much energy quickly, and the spacecraft fragments, and therefore we have a proliferation of spacecraft in this syndrome of propagation of debris failure, which might eventually disable some orbits. Therefore, if things go very wrong in an orbit, we might end up filling it with debris, and it might take quite some time to clean it up. Clean it up not by human means, by nature, especially if it's a lower orbit. Higher orbit are a bit more difficult to clean up.
Are you talking about Kessler syndrome, right? I know that
Indeed,
you met him.
Indeed, this Kessler syndrome is known since a long time. NASA, ESA, all the space agencies have been working a lot on this thing, always warning the user community that overdoing in space, not taking proper measure to limit the risk of explosion, can bring to this problem. And now it's becoming more real, because talking about Kessler syndrome, already in 2010, this was discussed. But still, it was a problem far away because of the lower number of satellites in orbit, substantial number of debris, but still lower number of satellites in orbit. Therefore, the risk appetite of the operator was still, and the agency was still okay. But nowadays, with the large number of constellations that we have in orbit and the ones that are coming, which are one order of magnitude maybe larger than what we have today, then the risk becomes more real, and therefore we have to do something to cope with this risk. Stuff is in orbit, stays there, some re-enters, all the rest is there and will stay there. So we have to manage it. We have to be aware of what is flying, and we have to be able to do something to avoid that. From an operator point of view, operators can keep doing business. From an overall environment point of view, to preserve the environment such that we can operate in the future the same way we are operating now.
I would like to focus on something that you said before, that we actually are not able to see all the debris that are actually in the orbit, especially in the nearest orbit, namely low Earth orbit. So with the current technologies that we have in the industry, how much are we actually able to see, and how much is unknown, remains unknown?
Yeah, that is the tricky part of the business. As I said before, a debris of 1 centimeter size or smaller can really kill a satellite. So it is not as dangerous as another satellite, but can still kill a satellite, can still generate a fragmentation, substantial fragmentation of a satellite. The problem is that technology, the one we have now, the way it's being done now, does not really allow to monitor this size of debris. So it's just at the infancy. We are comfortable, the way you also see in literature, with objects, let's say, above the 10 centimeter one. There we are more or less comfortable. It's a matter of being organized, but we can monitor, then predict where they are going to be with some level of precision. But objects smaller, they just come as a surprise. And we have know that one object, even small, can disrupt the operation of a satellite substantially, or can generate quite a large number of debris, which might lead to making one orbit unusable. Then there is an effort, it needs to be done for improving technology, for being able to monitor the small objects, I don't know, between 10 and 1 centimeter, or even going down lower. There are techniques available. It's substantial effort to be done from ground with optical means or radar means. And this brings to the fact that being able to observe the environment from orbit is quite an advantage, because you are closer to the problem. So with the sensors placed on a spacecraft, hopefully objects close to the 1 centimeter or even smaller can be monitored, and therefore once we are aware of where they are, what is going on, we can also manage the situation much, much better. And with time passing, with the presence of many more spacecraft in orbit, it is more important to do this monitoring of the overall situation.
Exactly. So indeed, because when you can observe the debris directly from orbit, you are also increasing the frequency of observation. That is maybe something that is critical exactly for the safety of the other satellites.
Indeed, observing then the frequency by which you observe the debris is higher, so you have a better understanding of what is going on. On top, we have to add that apart from increasing, technology has evolved with artificial intelligence and other means. The prediction of where the debris, once it's identified, where is the debris is going to be, the capability of predicting the probability of collision with a spacecraft is improving, and this goes all in the direction of making the life of the operator much easier, and all in all, making the operation of the very large spacecraft fleet that is now flying at the lower risk, all with the objective of preserving space for the future generation, because we have to make a responsible use of space such that future generation, our children and the children of our children, can benefit from space the same way we do. Because sometimes in the general public, they don't have a very good perception of the benefits of on everyday's life of space. And it is in everyday's life now, without space, cannot do normal business. Think of GPS, think of bank transactions, think of weather forecast, of natural disaster monitoring, and so forth. In addition, there are all the other activities related to national security and so on, which now make extended use of space, and which actually is even sort of extending the risks related to security to space, which is another area where being able to observe with a frequent revisit time and a good accuracy the object in space can be quite useful also for national security purposes.
Of course. So considering nowadays situation, just one last question before we wrap up, maybe the trickiest one. What do you think is currently missing in the space industry to tackle this challenge?
I think there is enough technology of observation in space, giving full coverage, because it's a matter, you might have a technology, but you have to have, it depends how much coverage you can give. So the time you manage to revisit the objects and so on. And there is also another aspect, which is a bit of disciplining a little bit the traffic, because once you know exactly what is happening, then you have to have some rules of behavior, some code of conduct. So what are you going to do with the thing? Because we have to keep in mind that the demise or the explosion of a spacecraft due to a debris hitting the spacecraft may be an acceptable risk for the individual operator, because the operator is to weigh the probability that the prediction is correct against the amount and the effort going into the avoidance maneuver. And on the other hand, we have the risk that this is to the overall community, to the environment, because the operator can afford losing one spacecraft that explodes, but the community, the overall community, the space users in general, cannot afford that that specific spacecraft explodes, generates a number of debris, which can eventually impair the use of one orbit. So, and in this area, I think there is a need, and this is happening, of introducing a number of regulations, a number of codes of conduct, and so on, because I think in space, the way space is being run, space does not belong to anybody, it belongs to everybody. So there is no real body who can impose firmly regulation, apart from the United Nations, but I don't think they will be able to go that far in a very short term. So the other element which is important, just putting some regulation. To launch a spacecraft, normally the operator needs a license. Therefore, the licensing authority can put some conditions. For example, spacecraft has to be built with some maneuvering capability and shall do avoidance maneuver when it gets a warning. So this kind of thing can improve the overall situation. I am afraid that things might eventually go worse before become better, but people become insensitive, and it might well be that we have one case of substantial accident, which for some time will be preventing of using an orbit. But this, unfortunately, is unavoidable. There's too much in space.
Maybe it will raise more awareness throughout the space industry about this challenge. So, Rosario, this has been a highly insightful conversation. Thank you very much for your valuable perspectives. And of course, like probably will be worth it to, in another interview, explore a bit more in deep this last topic you were talking about. So space regulation is also something worth talking about. But yeah, thank you very much for this introduction about space debris mitigation.
Thank you. Thank you. Bye-bye.
Thank you very much. Bye.